All right, for our last section of this chapter 9.7, we're doing marginal analysis in business and economics. So this is the idea you should have seen in economics. If you haven't taken it yet, then you'll probably see it later. But we're going to do it with derivatives. So that makes it a little different, obviously. So marginal analysis, the whole idea is if I make one more, what is happening to my profit, to my cost, to my revenue, right? That's kind of the idea, that one more. So I want you to think that when you think marginal analysis, right? So in our sense, we can look at um, cost, revenue, and profit. And hopefully you realize cost of an item, right? The cost, we always use a C. The cost is what you're paying for. So usually have variable cost per item and fixed costs like the place that you rent for your business or your overhead cost, right? Power, electric, well, power and electric, I think both are the same thing. Gas, power, all that kind of stuff, water. So costs are usually two different costs, variable and fixed. Revenue is our money coming in. So revenue is typically thought of as X times the price. So revenue is typically thought of, X is always our number of items. So maybe we'll put that up here too. X is typically your items, right? Your number of items, or maybe I'll put the number symbol up there. Number of items. So if I sell 20 items at the price of $1, I just made 20 bucks. That's my revenue. That's my money coming in. Whereas profit is where you subtract those two. I better hope all my money coming in is less than my cost. So if you get a negative number, you are not making money, right? You're in the negative. So that's kind of this idea here that you've seen in your business courses, but maybe if you're new to business and this is one of your first courses, you haven't actually thought that through yet. So marginal is where we take the derivative of all of the above. So anytime you hear marginal for us, we can take the derivative. Then we can put a value in like the number of items. So let's say we're looking at marginal cost. We could put in a 20, like 20 items, and the marginal cost will predict the cost of the 21st item. Okay, so one more. So I'd put in a 20 to predict the 21st. So that's the idea of marginal. Marginal is one more. This is just regular total cost profit. This is calculus. All right, then it goes through, oh my goodness, all these different things down here. So we could do cost like total cost, right? Or we could do cost per unit. So we have what's called the average cost. So if we have the total cost as C and X is our items, well, if I divide those, I can get the cost per item. Same with revenue, same with profit. So we, like the X bar that we do for a mean, we put a little bar on it. It's average, cost, revenue, profit. Okay. And same for marginal average cost. So you'll take the average and then you'll take the derivative of that average. Notice you do the average, then the derivative of that average. All right, let's take this cost and this revenue, and let's go through all of our different functions real quick. So this first one, marginal cost function. Okay, so it has the word marginal. So I'm going to go up here and I'm going to think derivative, marginal. So of just the cost. So I'm going to label that cost derivative of X, right? With the little prime symbol. And if we do the derivative of just the cost function right here, the 600 would go away because our numbers go to 0. And then we would have our negative 4x. Well, again, that x is an exponent of 1. So when I minus 1, it goes to 0. So the x goes away as well. So far I see negative 4x goes away plus, well, then I have to take 2 times 0.00306 times 2. So that's going to give me I'm going to do it as 0 point just so it looks a little bit better. 0.0012x, right? So the 2 multiplies by this and drop 1 here. Should be getting pretty good at that. And that's it. Marginal cost function. What's your average cost function? No marginal. So if it has no marginal, you're just doing the average of the regular cost function. So the regular cost function looks like 600 minus 4x plus 0.1236x squared. So if I want to now turn this into the average, I'm going to divide every single term by x. You could put it under all of it, but you can't simplify, and then you can't take the derivative. So we like to break up our x's because we need to be able to take the derivative. So then we don't have that extra step that you had to do in 9-5. Okay, so we could simplify these if we wanted. And our final answer would be average cost is going to be 600 with x underneath. You could write that as x to the -1 so that the next question, maybe I'll do that. So the next question, we would be ready for the derivative, right? So 600x to the -1, because I can see right here, marginal average. Our next one's going to make us do the derivative. This next term, the x's cancel, so I just have the number -4. And then you can see a square and an x. So one of the x's cancels with one of the x's up top. So I have plus 0.1236x because one of the x's canceled. So that's our average cost. Now the next one says, what is the marginal average cost? So we already found the average. That's the function above. So then I could take the average and take the derivative. So this first term, -1 times 600 is -600. Then minus 1 more here. So I'm going to have -600 x to the -2. Okay, what's -4 become? 0. It just kind of drops off for us. And then I have plus I'm going to do the 0.0006 because the x will drop off as well. And that's our marginal average cost. So then we're going to do all 3 functions that have to do with the revenue. Okay. But I don't remember the revenue, 1000x. Okay, so let's just write the revenue was 1000x minus 20x squared. Okay, so that's just our revenue function. So marginal revenue is going to say take the derivative, right? And we're not even using these yet, but we're just finding them at first. Oh my goodness. So marginal, that just becomes 1000. 1000x becomes 1000 minus 20 times 2 is 40. X squared becomes the x. Perfect. Now average revenue. So go back to the original and divide each term by x. So the average, I'm going to put the little line on it. My R's always start to look a little like, it kind of looks like that real number symbol. I don't know. So 1000 divided by x is just 1000. Minus 20 divided by x is 20x. I did not show all my steps. This is business calc. Hopefully you could follow, right? Put an x under this, put an x under this. I get this. Then marginal average revenue function. So marginal, now I want the average function, but take the derivative of it. So 1000 goes away. I just have -20. Oh, that does not look good. The marginal average revenue. I don't know what business we're in, but we should not be getting negative revenue. People are not, I mean, could you imagine what our profit's going to be if our revenue is negative? That's our money coming in is negative. Yeah, that's not very realistic. Okay. All right, give me just a sec. So for the next one, it's profit of all three of the same. Then we've done at least one of every single kind. Then we're going to start actually looking at business situations. So the profit function on this one, I got the paper out so I didn't have to start looking, right? The profit is going to be just profit in general. Oops, that should look like an R. So profit in general is going to be all of our money coming in minus our cost. So we actually take the two functions and subtract them. So you're always given revenue and cost, but you have to come up with the profit function on your own. So profit is going to equal, our revenue function was 1,000x minus 20x squared. And then you're going to subtract off, I'm going to use a parenthesis for the entire revenue. Oops, no, cost function. So revenue minus cost. So 600 minus, I thought I switched it for a second, 4x squared plus 0.1236x squared. All right, so notice I use a parenthesis around that just to kind of keep our negative in check, right? So this is our profit function. We definitely want to simplify before the marginal so that we can do the derivative a little bit easier. This is going to become a plus, that becomes a negative, positive, negative. So our highest one are the squares. So what is, what do we have? 20, right? And this ugly number minus it. They're both negative, so we're going to add those together. And so I get negative 20.0006 x squareds. Okay. And then our x terms, we have 1,000 and a 4. So 1,004 x's. And that we've taken care of that one, that one, that one, that one. And then a minus 600. All right, so there's our profit function. So they're a little more of a pain to do those. If I want marginal, I'm going to have to use my calculator. I don't know. Negative 20.0006 times 2, right? So I'm going to take the 2 and times it down here. Oh, I guess I could have thought of that in my head. Clearly I didn't though. So marginal is derivative of the profit, and that's going to give me negative 40.0012x. So 2 times the 20.006, drop one exponent, plus 1,004, and the 600 and x go away. So that's your marginal profit. Average profit function, we have to go back to the original profit, divide every single term by x. So average profit is going to be, so go down one term on each of the profit, right? So this one would become just an x, that one, it cancels with the x underneath, and that one you would still have the x underneath. So the first one's going to become negative 20.1236x, because the x underneath, plus 1,004 minus 600 with the x. Oops, that's going to be a 4, not an x. Love that I can erase. There we go. So that's your average profit. So last one is just the derivative of that one, right? For the marginal average profit. So the derivative of that is going to look like average derivative function. Negative 20.x is just negative 20.1236. 1,004 goes away. And for this last term, we probably need to think of this like this, right? That x has to come up as a negative exponent, and then the negative times the 600 would become a positive 600, and then x will become to the negative 2 power, which you could write back down underneath, but doesn't matter either way. Okay, so we just walked through every type. Now let's actually do some problems with it. So problem 11, consider the revenue in dollars as the following. Find the exact revenue of finding the sale of 101 items. So the exact revenue without what I'm going to show you is going to be, you have to find the revenue of the 101st and subtract the revenue of 1,000. in class, I always try to like make people think of that. Like, how can I find the 100th? Well, I have to know the revenue up until, right? Or the 101st, sorry. I have to find the revenue all the way up till that 100th item, all that revenue, right? And then I can find and subtract in order to get the revenue of the in between. So it's like all the revenue up to 101, all the revenue up to 100, subtract them, and I will get the 101st revenue. Tricky. Okay, so I'm just going to put these values into the function. So 1,000 divided by 101 plus 1,000 times 101. And then I'm going to do the same thing for 100. It'd be 1,000 divided by 100 plus 1,000 times 100. All right, so these are my functions. Oh my goodness. I'm just going to totally put this in my calculator, and I am going to cheat and read it off here. I got 999.9. That's what I got according to this method. So anytime you're asked for the exact, this is how you do it. Okay, now we're going to use marginal analysis, and we're going to estimate the next one. So B, way quicker usually, is use marginal revenue to approximate this. Okay, so marginal revenue, I'm going to do the derivative. So the revenue derivative. Okay, so this 1,000x can be written as 1,000x to the -1 plus the 1,000x like that. So it's a little easier to do our derivative. So -1 times 1,000 is -1,000x. So I minus another one off. I get -2 plus 1,000 because the x term goes away. So we're here. Okay, then from here, what do we put in to predict the 101st? Okay, the whole idea is it predicts the next one. So we have to put in 100 to predict the 101st. That's a big idea for this chapter. Okay, so then I have a -1,000, and then I put in the hundreds to the -2 plus 1,000. And you could type it in just like this. You could have moved the x squared down and done the division. Either way, this one turns out to be 999.90. Oops, same answer. Sometimes they're off a little bit, but not much, if not exact. So exact and using our new method. Okay, so problem 12. Total cost in dollars of manufacturing. So this is a cost problem. Find the average cost per unit if 300 units are produced. Okay, so A says, find the average cost. Any derivative needed? Any actual calculus needed? Nope. Right? Average cost. We don't need anything to do with calculus because there's no marginal word in there. So average cost is just taking the cost and dividing each term by x. Okay, which happens to be 300 on this. But if I simplify this, these x's will cancel, and then I can put in the value of 300. It ends up being 10,000 divided by 300 plus 15. Now you could have just put it in up above too. You would have got the right answers either way. Okay, so 10,000 divided by 300 plus 15, I get 48.33 repeating. So we always like to round to the nearest dollar. So the average cost for every single unit at 300 units made is $48. Why do we have to specify 300 units made? Isn't it the same if I make 100 units? No, right? Think about your big overhead fixed cost. The more units you make, the more that overhead cost is less. So it's actually cheaper as you go into more and more production. Another way to think of it also is if you were like needing this part for all of yours, if you buy that in bulk, you're going to save money versus buying less. So as you make more, it costs less. So at every single level, it's going to be a different cost. Okay, what's B? Find the marginal average cost at production level 300 and interpret your results. So I want the derivative of the function. So this is average cost, but now we're going to do the derivative. So if I look up here, this is the same as 10,000 x to the negative 1. So it becomes negative 10,000 x to the negative 2 when we take that derivative. Okay, and then 15 drops off because the x is canceled here, right? So that's it. That's your derivative of the average. Then at what level are we looking at? 300 units. So we're going to put in the 300 and I get negative 10,000. Oh, I think, yeah, I did an extra zero on that. And then it's 300 to the negative 2. And again, that 300 could be in the denominator, but I get negative 11 cents. So the marginal average cost at the production level of 300 units is 11, going down 11 cents. So what is it going to cost for that next item? It's going to be 11 cents less. So what is $48.33 minus 11 cents? $48.22. So that's what the cost will be at the 301st, which is what they're asking in part C. Use the results in part A and B to estimate. Okay, so right now we're at $48.33 at 300. So we would minus the 11 cents to get the $48.22. Okay, another way I could have gotten that is I could have done to get the results of the average cost per unit. Yeah, average cost. I don't know. I was thinking of a different way and then I kind of lost my train of thought. So we're not gonna worry about it. Okay. So if you do this and you figure out what you're gonna have your rate change, right? Then you can kind of predict that next one that way also. All right, alrighty. 13 and 14. So 13, the total profit is this, and exact profit and marginal profit. So this is the same one we've done before, but it's with the profit function. How am I going to do the exact profit of the 201st item? Hopefully you thought I have to put in the 200 and 201st into the function and subtract them. So I do the profit at the 201st minus the profit at the 200. And usually you have to find the profit. This one was nicer. Usually you have to take the revenue and subtract the cost to even get to your profit. So if I did this in mine, I'm going to just cheat and tell you the answer is $17.97. Why? Because I think you can plug in the numbers and subtract them. It's not pretty. You have to plug in 201, 201, calculate it all out, get an answer here, then put in 200 and 200. But I think you can do that. So exact is more of a calculator game and a little bit of a pain. Okay, this is my favorite one, marginal profit. So we're going to start with marginal profit, just the function, right? The equation for that. And that is the derivative of the profit. So we're going to have 30 minus 0.06x, and then the 200 drops off, right? Because we go, this just becomes 30. 2 times 0.03 is 0.06. Keep your negative, and then that drops to an x, and we're there. So then, how do I predict the 201st? I put in the 200th Okay, so 30 minus 0.06 times another 30, and I get 18. Okay, this is one there, they're close. 2 cents, 3 cents off, but they're not the exact same. But doing the derivative method is a lot quicker. It's actually easier to program as well if you're programming like a program, because a lot of math programs can now do the derivative for you in a computer setting. Okay. This last one is the same thing. Let's see if there's anything real different on this one. No, I think I'll skip it. It's exactly the same. The problem with this one and why I'm going to skip it is it's asking for cost, revenue, and profit of every single thing. So it's saying here, like, to take the profit function, which we can find revenue minus cost, and then it wants you to do cost, revenue, and profit of making the 101st. So then you have to put in the 100th and then the 101st in every single function, all three, and subtract them. Then you can do the marginal, the derivative, and put in the value of 100 into all three. So I think you got the idea. That's actually a super long, not super long, a long problem. This is similar to something I'd put on an exam because it kind of makes you do all three in one problem. Okay, that's all I got for this video.